All right, so Newton's first law. Newton's first law says that if an object does not undergo any acceleration, then there's no net external force, or the other way around. Newton's first. So basically, if the net force is zero, then we have zero acceleration. And it goes both ways. So if the acceleration is zero, then I know that the net force is zero. And notice that this is net force, so it's the total force, not individual forces, because we can still have forces acting. It's just that if we add them all up, they all zero out or cancel. So this acceleration, though, acceleration is zero. That implies that the velocity is constant. So we have constant velocity. So velocity is constant. And that could be, the velocity could be zero, or it could be greater than or not equal to zero. So it could be either static or in motion. Static is at rest. Motion would be called dynamic. And both of these are equilibrium. All right. So the idea here is we're able to solve these problems relatively easily. If we know that they're not moving, then we'll just we know that all the forces add up to be zero. Not a big deal. So let's look at a couple examples. An orangutan is hanging from a vertical rope. So we'll assume the orangutan is a sphere, and it's a rope, so that's called tension. And then he has the orangutan has some mass. Therefore, there's a gravitational force on him. And the gravitational force is equal to 500 newtons. That's his weight. And we want to know what's the tension. Now, you could just look at this and, since it's in equilibrium, it's not moving. Why isn't it this marking? Okay. We know that these are going to have to be equivalent. But let's see why. So we know that they're zero. So we know that the acceleration is equal to zero. And acceleration, you know what? Let's not go that route. Let's just say, okay, so the net force is going to be zero. So now we just add up the forces. So it'd be my tension force plus my force of gravity is going to be equal to 0. So the tension is going to be the opposite of the force of gravity. And we know that the force of gravity is 500. However, the component, the Fg in the y direction, that's negative. So negative 500 N. And so I know that this has to be positive. So the tension force is going to be also 500 newtons. Yeah? All right. Let's look at another example. So we have a wrecking ball. It weighs 2,500 newtons, and it's hanging from a cable. Prior to swinging, it's pulled back 20 degrees to a 20-degree angle by a second horizontal cable. What's the tension in the horizontal cable? So what we have is we have a wrecking ball, and suppose it was like hanging over here, and then it's been pulled back so that it's hanging at some angle, like so. And this is a cable, so this is tension. And then we'll call that tension in the vertical direction. And we know that this angle right here is 20 degrees. And this thing does not like to do little stuff. Okay, 20 degrees. And then we know that there's a cable pulling it back, and the cable pulling it back is in the horizontal direction. So we'll call this tension horizontal. And then we have some force of gravity pulling down. And the force of gravity is 2,500 newtons. All right. So what we want is we want the tension in the horizontal cable. So this is what we're looking for, the tension in the horizontal. And what we're going to have to do is we're going to have to work with components because I have this angle over here. So what we'll do is we'll throw in this Tx. This is TV in the x. and TV in the y, which would come up like this. I know my arrows aren't very good. All right, so we have equilibrium. So equilibrium says that the net force is equal to 0. And what this means is that my components in the x and y direction are also equal to 0. So the sum of the forces in the x is equal to 0, and the sum of the forces in the y is also equal to 0. And so we break it out. Well, that's just how we do it. We have to analyze these independently. So my forces in the x direction would be this TV in the x plus the TH. And notice H, I didn't have to put any components because this is all in the x direction. So it's anything that's moving in this direction is equal to 0. And I'm trying to find the tension in the horizontal. Oh, look, I can just, this is it right here. I don't even have to work in the y, or maybe not. Let's see. So I know that my tension in the horizontal is going to be the opposite of T1 in the x direction. Yeah? You know what? I'm going to change this real quick. All right, so now let's, you know what, we're going to have to, because I don't know what I don't know what this is. I don't know what this is, so I can't figure out, or I don't know what this is, so I don't know what the magnitude is here. But I know that this is going to be the same magnitude, just opposite direction. So now let's go to the y and see what we can do. So my forces in the y will be TV in the y plus the force of gravity is equal to 0. So TV in the y direction is equal to the opposite of the force of gravity. But TV in the y direction, since it's next to the angle, that's going to be TV cosine 20. Be negative FG. And so TV is going to be negative FG over cosine 20. Okay, I can plug in some numbers and get that. But the reason that we're getting at TV is because now I can go back over here and this TV in the x direction, sorry, I put T1. TV in the x direction, well, the tension in the horizontal will be TV in the x direction will be sine, so it's going to be TV sine 20. So all I need to know is I need to know TV. So we can plug in our values here. We can plug in the 2500 over cosine. That will give us TV. Then we get the sine multiply that by sine 20, and that will tell me TH. I'm not going to finish that because that's pretty much done. It's just calculation. So now we're looking at dynamic equilibrium, and I know it's dynamic equilibrium because I see this steady speed. Steady speed means constant velocity. Okay, so we have a car. It has some mass. So it's being towed at a steady speed by a rope held at 20 degrees above the horizontal. So we have a car. It's being towed by a rope. So we have some tension here. And this is at 20 degrees. Okay. I could put a little dotted line. We don't need to. And then I'm going to have some gravity. So I'll have the force of gravity here, which is equal to mg. And then it says that there's a friction force that opposes the motion. So I would have a friction force in this direction. This would be my force of friction. That didn't help. And this is going to be 320 newtons. And then it says, what's the tension? So we're looking for that. So again, it's steady speed, so that means that the net force is 0. So you see, net force does not mean that it's sitting still. It can be as long as it's constant velocity, whether it's 0 or not. So we can get the net force in the x direction is equal to 0, and the net force in the y direction is also equal to 0. So in the x direction, I'm going to have my tension in the x direction and then I'll have tension in the y direction. And we can go either route. We can look at the y's, or we can look at the x's. So let's look at the x's. So I got Tx plus the force of friction is equal to 0. So Tx is going to be the opposite of the force of friction. But I'm looking for the tension. So if I can get Tx in terms of tension, I'll be done. And I can because it's next to it. So it's going to be T cosine 20 is equal to negative force of friction. So the tension is going to be the force of friction divided by cosine 20. And so we're done. We would just calculate that. The force of friction is 320, but it's to the left, so it's negative. So I got negative 320. That's where my positive comes for, divided by cosine 20. And you just plug that in a calculator. That would tell you your tension force. We could also do it in the y direction, figure out the same thing. So in the y direction, I would do Ty, this one, plus the Fg is equal to 0. So Ty is equal to negative Fg. So Ty, if I put it in terms of t, that would be t cosine 20 is equal to negative Fg. And t is going to be negative Fg divided by sine 20. And where Fg is mg. So we would just multiply 1500 times 9.8. Divide, we should get the same thing. And that's it. Those are a few examples. So now you can practice on your own. I'll give you some solutions. Or rather, you'll just have a practice. I'll tell you if you're right or wrong.